and now started the generation of sinusoidal AC voltage. How the voltage and current is generation here, and this diagram I explained yesterday. Little bit about that one here. So brief explanation of that one. For 1 to 2 here now means from 0 to 90 degree, the flux linkage will be from vary from 0 to maximum. So at 0 angle time, the flux linkage to this single turn coil is 0. So that time EMF induced in this coil will be 0. And literally in the anti-clockwise direction, it started to rotate. And that situation, what will happen? Some flux linkage will occur to this single turn coil, and the EMF will induce us here. That EMF will vary lightly when the how it is start to rotate. When it will reaches to 90 degree, then the maximum flux linkage will occur, and the EMF induced will be maximum here. So here 0 to 90 degree it will maximum. Then after 90 degree, then again it will start to rotate little bit, means it will become 120 degree. Again the flux linkage will be decreases. Then the EMF induced will be decreases. Once it will reach just to 180 degree, the terminals are reversed and flux linkage will be 0. After 120 degree, 180 degree, will happen again. The flux linkage will start to increases, like that EMF will start to increases here. So up to 270 degree, the flux linkage will increases. At 270 degree, we will get the maximum EMF, and after 270 degree again, the flux linkage will be decreases and EMF will be decreases in this one. So it will complete one cycle of that one. This is completely one cycle we are going to tell that one. This one already you have taken in the last class yesterday. Explanation you have taken, yes? The diagram is already over.
Yes, sir. Diagram.
Okay. Below the diagram, you write down. Below the diagram, niche go. Consider a rectangular coil of consider a rectangular coil of n turns placed in a uniform magnetic field as shown in above figure. Good point. The coil is rotating. In the anti-clockwise direction. At an uniform angular velocity of omega radian per second. Full point. When the coil is in the vertical position, next line. Hello.
Yes, sir.
Okay, continue this one. You write. You take this all right up. or
Wait, sir.
when the coil from here I start the dictation of better. When the coil moves by some angle in the anticlockwise direction, there is a rate of change of flux linking the coil, hence an EMF is induced in the coil. EMF will be induced in the coil. When the coil reaches the horizontal position, when the coil reaches the horizontal position, the flux linking the coil is maximum. Flux linking the coil is maximum, and hence the EMF induced is also maximum. EMF the induced is also maximum. Right. When the coil further moves in the anti-clockwise direction, when the coil further moves in the anti-clockwise direction, comma, the EMF induced in the coil, reduces. Next, the coil comes to the vertical position. The coil comes to the vertical position. The EMF induced becomes zero. After that, the same cycle repeats. Same cycle repeats, and the EMF is induced in the opposite direction. The EMF induced in the opposite direction. When the coil completes one cycle revolution, one complete revolution, one cycle of AC is generated. One cycle of AC is generated. Full point. Up to here, all of you are taken.
Wait, sir.
Still wait करना है क्या? After completing, you just let me know. Or
Yes, sir.
Yes, sir.
okay. To take this all four diagrams, this one, this one, this one, and this one. This is first one, second, third, and fourth one. Take all diagrams, all four diagrams you take down. Here, these four diagrams, it will do the one complete cycle actually. One complete cycle will use here. Actually, the plane is like this here now. The same direction of the plus linkage here now. So the plus linkage will be zero here. Plus linkage will be zero here. Next, the 45 degree, it will rotate in the anti-clockwise direction. Anti-clockwise direction, the single turn coil will rotate 45 degree. Some fluxes are passing towards here now. So linkage will occur here. Some flux linkage will occur here now. So the EMF will be induced in this single turn coil, and that one we are taking out here now. And from 45 to 90 degree, what it will happen? At 90 degree, it will horizontal plane now. The coil is horizontal plane, but the flux linkage is in vertical here now. So maximum all the flux lines pass through this coil only. So the flux linkage will be maximum here. Because of maximum flux linkage, the EMF induced is also maximum at 90 degree. At 90 degree, maximum EMF will be induced here now. So from 90 degree, what will happen? It will move towards 120 degree next. 90 to 120 degree it has moved here now. So from 90 to 120, what will happen? The flux linkage will again, here the maximum, here some reduces here now. Flux linkage will be reduces here now. So the voltage will be, EMF induced will be decreases here now. So 90 to 120, it will decrease here. From 120 to again 180 degree here. 180 degree, what will happen here now? Then that is 180 degree, it will completely zero, it will come over there again, because there is no flux linkage at hand. From 122, next, how much it is? 165 degree. 165 degree, here it will like this here. Next 270 degree, it will maximum. Next for the 270 to 180 degree, again it will decrease here. Like that, but the after 180 degree, what will happen? The EMF induced will be reversed here. The terminals of this one A, B, we have not given actually. Here A, B, C, D we have given, means while rotating in the anti-clockwise direction, the terminals will be reversed. While collection the AC supply, the positive will become negative, negative will become positive. For every cycle will alternate power will be generated. A positive, negative, positive, negative. For that reason only we are going to call this one as alternating current. So whatever the EMF induced is there, alternating current we are going to call that. Diagram is over. I've taken the diagram. Over. Hello. Over or not?
Yes, sir.
Is it over?
Yes, sir.
Okay. Next we will go for the next diagram, that is the generation of, is it audible or not?
Yes,
Yes,
sir.
sir.
The generation of, next line you write down, the generation of sinusoidal AC voltage, the generation of sinusoidal AC voltage can also be explained, can also be explained, be explained can also be explained using mathematical equations, using mathematical equations, full point, consider a rectangular, consider a rectangular coil, consider a rectangular coil of n turns placed in a uniform magnetic field, placed in a uniform magnetic field in the position shown, in the position shown in the above figure, the position shown in the above figure. Full point. Today the strength is looking very good. 60 students are present. Okay. Next line. The maximum flux linking, the coil, is in the downward direction, as shown in the figure, full point. This flux can be divided into, two components, comma, one component acting along the plane, of the coil, acting along the plane of the coil, phi max sin omega t is nothing but phi m sin omega t, you write down. phi m sin omega t, phi m sin omega t, and another component and another component acting perpendicular to the plane is phi m cos omega t, phi m cos omega t, phi m cos omega t. Full point. Listen carefully here now. See, perpendicular, this plane is perpendicular to the this horizontal axis, plane of the axis of the single line conductor here now, one line conductor here now. So it is like a triangular here now. Sin omega t, opposite, adjacent, hypotenuse, we are going to call like that. This is whatever the phi m is there, flux. This is the x-axis, we are going to horizontal one, phi m sin omega t we are telling, and vertical line we are considering as phi m cos omega t. Listen carefully, don't take now here. The component of flux acting along the plane of the coil does not induce any flux in the coil here now. Whatever the flux acting along the plane of coil is the plane, same plane of the coil is there, that it does not induce the EMF in that. Only the component acting perpendicular to the plane of the coil, that is phi max, phi m cos omega t. At this phi m cos omega t only, maximum it is phi max is there. Here it is perpendicular to that, then only the maximum EMF will be induced. But we know that one, according to the formula of Faraday's law of electromagnetic induction, here we know that one E equal to minus n d phi by dt. We know the formula or not?
Yes, sir.
Yes.
Minus n d phi by dt, we know the formula here.
Yes.
So at perpendicular axis, the maximum flux when we are going to get here, when phi m equal to cos omega t, when the axis is perpendicular to the plane, on that situation phi m cos omega t is there. So this phi m equal to phi m cos omega t we can write on. In the place of phi, I will substitute phi m cos omega t here now. At the perpendicular, the phi m cos omega t I will consider here now. So in the place of phi equal to phi m cos omega t, while when the EMF is inducing here now. On that situation, because it is whatever the angle is there, the omega t here now. Based on the cos omega t, the angle will be, maximum flux will be decided here now. So flux is not constant here now. At the horizontal axis it is 0, little bit increased means it is increasing here now. At perpendicular axis of the plane, that is maximum here now. So on that situation, what is the cos 90 equal to? Cos 90 equal to what?
0.
0.
So but cos 180 degree, again 0 it is, like that. One it will come. So based on that one, what we'll do, at any instant we can tell that one cos omega t is nothing but at any instant we are going to get the value of phi here now. So phi equal to phi m cos omega t I will substitute. In the place of phi here, I will substitute phi m cos omega t. The phi m I will take outside here now. Cos omega t is there here with respect to the differentiation with respect to the dt is there. So differentiation of cos omega t with respect to t, differentiating that one, what is the answer?
Sin omega t.
Minus sin omega t into my omega.
Minus
Sin omega t.
minus sin omega t. Yes, correct here. Minus sin omega t is the correct answer here now. Minus sin omega t into omega sin 2x with respect to dx. Actually, differentiation with respect to x, sin 2x is there. Omega
Minus
is
minus
equal to now.
Sir, minus
Minus plus होते हैं तिथं.
Where? Okay, already it is there. No, minus.
minus
Minus plus होते.
One minus is there. Okay, that minus and this minus, it will become plus here
Yes.
now. So n I will keep as it is, phi m I will keep as it is. The differentiation of cos omega t is nothing but omega sin omega t. So minus omega sin omega t and minus plus it will become. So omega sin omega t I will write as it is here now. So this is equation number 1 here. Equation number 1. When the flux linkage EMF induced in this coil will be maximum?
EMF induced in this coil will be maximum when
90 degree.
When it turns to
Yes, 90 degree.
when 90 degree it will turns, the EMF induced in this coil will become maximum. So here in the above equation, when the coil turned to 90 degree, sine 90 equal to 1,
Yes, sir.
sine 90 equal to 1, and on that situation 90 degree, then E has a maximum value. That is, we can write EM equal to N phi m.
Yes, sir.
We can write
Yes.
EM equal to N phi m. We can write down. Yes. So
Yes,
now
sir.
here this EM equal to N phi m omega also you have to write down. Yes, here omega we are not substituting anything no, here.
Yes, sir. Okay.
Sir.
Yes.
Just a minute. Okay, N phi m omega, that is nothing but maximum induced EMF here now. When the coil is turned to 90 degree, on that situation omega t equal to 90 degree we can consider, sine 90 equal to 1. So E is nothing but, it is nothing but a maximum value we are going to get. So this E we are going to write EM. EM is the EMF induced, maximum EMF induced equal to N phi m omega I will write here now. So substituting this second equation in equation number 1, where N phi omega is there, on that place I will substitute EM here. EM is substituted over there. Yes.
Yes, sir.
So E equal to EM sine omega t we can write down.
Yes, sir.
Yes,
E
sir.
equal to EM sine omega t we can write down. Hence the EMF induced in the coil is a sinusoidal EMF. This will induce sinusoidal current in the circuit given by, similarly we can write I equal to Im sine omega t. What is the heading here now? Generation of sinusoidal AC voltage or current. I have told that one actually. Voltage and current is there here now. So based on the voltage equation, we can write the current equation also here. We can write the current equation also. So this is, I will remove this complete diagram, then it will become easy for you people. You can treat it. Is it visible now clearly? So I equal to Im sine omega t, E equal to Em sine omega t. This is the EMF induced here now. Sinusoidal AC voltage equation. This is the current equation here now. Is it clear? If you have any doubts, you can ask now only. See here, this omega you can write like this. Otherwise, directly we can write this one. D omega by dt is there, na? Directly d and d phi by dt. Okay, no problem. No problem here. You can substitute this complete term by EM. Take down. Take this one. किसी को कुछ doubt है तो पूछ सकते हैं. You can ask the doubt meanwhile and you can take the notes also. The component of, next line you लिख दो, next line. The component of flux, acting, the component of flux acting along the plane, the component of flux acting along the plane of the coil, along the plane of the coil, does not induce any flux in the coil. Does not induce any flux in the coil. Full point. Only the component acting perpendicular to the plane of, only the component acting perpendicular to the plane of the coil, that is phi m cos omega t phi m cos omega t, phi m cos omega t induces an EMF in the coil. Induces an EMF in the coil. You do one thing. First, you take this diagram. All of you take this diagram. A diagram ले लो. Take this diagram. And next, after this diagram, you can take this derivation. First, you take the diagram and let me know. Diagram होने के बाद बोल दो मेरे को. After completing the diagram, you just let me know. The diagram is over, then you can tell me, then I will proceed for the next. Over.
Yes, sir.
Diagram is over. Next line, write down. We know that E equal to minus n d phi by dt. E equal to minus n d phi by dt. Next line. E equal to minus n. You write one more equation here now. E equal to minus n phi m. In the place of phi m, I will write here. In the place of phi, I will substitute d phi m cos omega t divided by dt. D phi m cos omega t divided by dt. E equal to minus n d phi m cos omega t. The beside you write down phi equal to phi m cos omega t. Control V. The bracket में लिख दो अच्छा 3 डॉट्स रखते हैं ना, देयरफॉर को अपोजिट क्या बोलते हैं उसको? हेंस नहीं है, वेयर फाई इक्वल टू फाई एम कॉस ओमेगा टी, ये लिख दो अभी. वेयर फाई इक्वल टू फाई एम कॉस ओमेगा टी. द राइट साइड यू राइट डाउन वेयर फाई इक्वल टू फाई एम कॉस ओमेगा टी. नेक्स्ट लाइन E equal to minus n phi m we have taken outside here now. N phi m d cos omega t divided by dt. So cos omega t, we have to do the differentiation with respect to time here now. With respect to time here now. So minus sin omega t, will get that one, minus minus plus here now. So E equal to minus n phi m omega sin omega t. Omega sin omega t. This is equation number 1. Write it in the box. Write it in the box. Box में लिखे, like this you write in the box. Over.
Yes, sir.
Okay. Next, when the coil turn to 90 degrees, when the coil turn to 90 degrees, when the coil turned to 90 degree, then EMF induced in the coil E, EMF induced in the coil E, EMF induced in the coil E has maximum value. E has maximum value, that is write this equation. EM equal to n phi m omega, n phi m omega. Write this equation number 2. Write this one as equation number 2. Write that one as equation number 2. Equation number 2. Next line. Substituting equation number 2 in equation number 1. Equation number 2 in equation number 1. We get E equal to Em sin omega t. E equal to Em sin omega t. E equal to Em sin omega t. Em sin omega t. बॉक्स में लिखो ये कंप्लीट बॉक्स में लिखो. नेक्स्ट लाइन. hence the EMF induced in the coil and hence the EMF induced in the coil is a sinusoidal EMF. Hence the EMF induced in the coil is a sinusoidal EMF, sinusoidal, sinusoidal EMF. Full point. This will induce a sinusoidal current. This will induce a sinusoidal current in the circuit. Given by I equal to Im sin omega t. I equal to Im sin omega t. Im sin omega t. Im sin omega t. बॉक्स में लिखो. Over. Next line you written where EM is the maximum induced EMF. EM is the maximum induced EMF. IM is the maximum current. And and phi m is the maximum flux, and phi m is the maximum flux, full point. So it completes the generation of alternating voltage here now. This is the generation of alternating voltage. It will complete now. So the next heading is nothing but average value. I think average value we are going to consider here now. See here, average value means what will happen. I will tell you people here now. Suppose 10 members है अभी क्लास में, ओके अभी तुम्हारा घर में कंसिडर करो 10 मेंबर्स है, 10 मेंबर्स हर एक लोग, एक आदमी क्या करते 5 रुपए लेके आते, एक आदमी 6 रुपए लेके आते, एक आदमी 10 रुपए इनकम करते, एक आदमी 100 रुपए करते, लाइक दैट। ऐसा 10 आदमी का डिफरेंट वैल्यूज इनकम डिफरेंट है। हाउ विल टेक द एवरेज ऑफ दैट वन? How will take the average of that one?
Sum of income
Addition
divided
of
by
one.
persons.
Sum of income divided by
Persons.
persons.
Members in family.
Obviously, like that, we are going to do that one here now. Average income or average, whatever that one, average profit also we can tell that one. Average profit we can tell like that. Yes, some people they are bringing to the house means that is some profit we are going to tell that one. If 10 members they are bringing some amount and another some 5-6 members, that all amount they are expenditure in expending in the house. What is the net value now? Net average value. Average of profit कितना हो गया अभी? Average of profit
0.
Suppose I will tell you clearly, 10 members, है 10 members, some amount they are bringing, कुछ तो amount लेके आ रहा है, उसका summation divided by number of members you can by doing that one, it will give the answer, it will give the average value. Suppose 10 members में 5 लोग प्रॉफिट में है, वो इनकम लेके आ रहा है, अनदर 5 लोगों के क्या है, वो लॉस में है, सो वो लोग का उधर पहला 5 लोगों का माइनस प्लस में है, नेक्स्ट 5 लोगों का माइनस में है, देन आंसर विल बिकम 0, एवरेज आंसर वैल्यू विल बी 0.
Yes, sir.
Yes, sir.
So like that, in the AC supply, here AC supply, first half cycle is positive, second half cycle is negative. Average value of the full cycle is will become what here now?
0.
0.
Average value of full cycle will become 0. So for the average value, we cannot do for the full cycle. Full complete one cycle we should not consider here now. We have to consider only for the half cycle we are considering here now. Here 1, 2, 3, 4 like that we have written, huh? From 0 to here. How many? From only for the half cycle only we are going to consider the average value. So average value means summation of all divided by the number of terms, like that we are going to consider. Here the average value is the arithmetic average of all the values of an alternating quantity over one cycle is called its average value. Actually complete one cycle arithmetic average of all values का average निकलना है, that is called average value. But for the symmetrical waveforms, the average value calculated over one cycle becomes equal to 0, है ना? अभी symmetrical waveform positive half cycle है, negative है, इधर positive है, इधर negative है. So average of that one for over one cycle will becomes 0, because the positive area cancels the negative area. Positive area and negative area gets cancelled, na? Then what is the average value? Average value will become 0 for the complete one cycle here now. Hence, for the symmetrical waveforms like this, positive and negative or AC terminals, alternating voltage or current here now, the symmetrical waveforms, the average value is calculated for the half cycle only. We are going to calculate the average value only for the half cycle only. We are going to consider it may be positive half cycle or it may be negative half cycle. Almost the positive half cycle only we are going to calculate here. Yes. Is it clear now? Average value ka definition,
sir.
it will say that one the arithmetic values of all the summation of that one. Here it will give the average value. Okay, arithmetic of all the values of an alternating quantity over one cycle. One cycle is called average value. But for the symmetrical waveforms, the average value positive and negative gets cancels here. No, so for that reason, while calculating the average value for this waveforms, this type of AC waveforms, only first two half cycle we are going to consider here. We are going to consider here. So take the heading of average value. Average value, you take the heading. Take the heading of average value. Only definition you write down. The arithmetic average of all the values. The arithmetic average of all the values of an alternating quantity. All the values of an alternating quantity and alternating quantity over one cycle is called its average value. Over one cycle is called its average value. Its average value. Full point. Next line. For symmetrical waveforms, the average value calculated over one cycle, the average value calculated over one cycle becomes equal to 0, because the positive area cancels the negative area. Because the positive area cancels the negative area. Positive area cancels the negative area. Full point. Hence, for symmetrical waveforms, the average value is calculated for half cycle only. The average value is calculated for half cycle. The average value is calculated for half cycle. So we'll stop here only. This derivation we will discuss in the next class. We will discuss this derivation. We'll stop here only.